Hello, dear students. I'm glad to meet you at our course. Today we are going to talk about technological trends in high-rise buildings. Let's start. High-rise buildings were often designed in the form of rectangular blocks with glass facades. Such buildings, although practical and aesthetic, are somewhat monotonous. Contemporary architecture is trying to face this monotony. Apart from the mass execution of rational high-rise buildings, the appearance of another trend has been noted. This is the phenomenon of erecting iconic buildings, which are distinguished by their shape and scale. Based on the information gathered in the Council of Tall Buildings and Urban Habitat (CTBUH) database, it is reasonable to believe that the next generation of tall buildings will be more towards aerodynamic and curvilinear shapes and forms. The analysis of wind action on tall buildings showed the importance of the effect of form and geometry of high-rise buildings. Geometric solids such as polyhedra, cones, cylinders, spheres, ellipsoids, and terraces, and curved surfaces appear as the components of each modern skyscraper. In addition to creating the composition of a building, different kinds of distortion of the solids or surfaces are used. Generally, spatial forms can be geometrically divided into polyhedra, solids of revolution, and surfaces. Polyhedra are solids limited by a closed surface and constructed with a finite number of fiat polygons. They are divided into prismatoids, pyramids, prisms, antiprisms, and octahedrons. Polyhedra, Platonic solids, semi-regular polyhedra, and Archimedean solids. Other polyhedral compounds, Catalan, Johnson, and toroidal. The second group of geometric forms is the solids of revolution, which are limited by a closed surface of revolution or toroidal based on a circle, ellipse, or another closed figure. A sphere, ellipsoid, or toroid of revolution with a normal section in the shape of a circle or ellipse are the solids of revolution. The last group of spatial forms is surfaces, which include ruled surfaces, Catalana, conical and cylindrical, curved surfaces of a constant generatrix, rotary, toroidal, and translational, and curved surfaces of a varying generatrix, wedge, parabolic, elliptic, and minimum. From an architectural point of view, modern skyscrapers can be categorized into the following groups: extruder, rotor, twister, torus, and also freeform. Extruder and rotor. Buildings of this type have the same cross-section for their full height. An example can be a rectangular or a cylindrical solid. Within this group, the following modifications may exist. Individual stories are arranged one on the other in a constant slope, and the floor plans may have a straight or curved contour, anglers. Stories are arranged one on the other, sometimes with a different angle of inclination and often in the form of straight segments inclined in different directions that are smoothly connected to the curved segments, sliders, which may be narrowing with an increase in height, tapering sliders. Single buildings of this type can be connected in groups to provide increased rigidity or fire protection exit slider assemblies. Twister and torus. Buildings of this type are in the form of a twisted solid with a twister facade repeated on all floors. Buildings with an orthogonal core and one or two twisted towers belong to the category of torus. The conversion tower axis of the helical form of the revolution tower may be derived from the orientation of asymmetric floors not through the center of the circular segment stories, but the center of gravity of the floor. The body of the building belongs to the category of sliding twister, where the floors are moved upward along the 2D or 3D curve, and rotation is added to the outer structure. When the 3D curve rotation has the shape of a spiral, it belongs to the category of helical twister. The intersecting body of the building, in the shape of a twisted spiral, has an internal vertical zone dedicated to the lift shaft. Freeform. The free geometry building form is constructed using a combination of geometrically simple objects, lines, surfaces, and solids, when the sequence of the architect's action is not obvious and the form does not fit into any other category. In this category, we can distinguish the subcategory shear. It includes buildings that have a curved facade with balconies and other extended elements. The relationship between structure and architectural form has reached its peak in present times. Form and structure have become inseparable and complementary. The primary structural skeleton of a high-rise building can be visualized as a vertical cantilever beam with its base fixed in the ground. The structure has to carry vertical gravity loads, the lateral wind, and also earthquake loads. The building must therefore have adequate shear and bending resistance and must not lose its vertical load carrying capability. Structural systems of tall buildings can be divided into various types due to different criteria, for example, internal and external. The choice of a system and application of constructional material is affected by many factors, in particular, the height of the building, the ratio of height to width slenderness, the required special rigidity for the transfer of lateral forces, wind, seismic, the formation of the building's body, the conditions of the layout of the lower floor and foundation. The structural system of high-rise buildings can be divided into the following types: rigid frame, shear truss frame, shear wall frame, flat plate mega-column frame truss, core mega-core, outrigger frame, and tube, frame tube, truss tube. Currently, the Diagrid diagonal grid system is one of the most innovative and adaptable approaches to structuring high-rise buildings. Capital Gate Tower, Abu Dhabi, UAE, Swiss Re, London, UK, Hearst Tower, New York, USA, and CCTV headquarters, Beijing, China. This kind of structure has evolved from a diagonalized tube. A diagrid is a special form of a special truss. The difference between a conventional brace tube structure and the current diagrid structure is that the diagrid system has almost eliminated the use of columns. This is possible because diagonal elements in the diagrid system can carry gravity loads as well as horizontal loads due to their triangular configuration. The constructional function is realized by the transfer of lateral loads through the actual action of structural components. Thank you for your attention, dear students. Next time we are going to study high-rise buildings in the world. See you next time. Goodbye.